Raymond Foo from EMSNow here at Nihon, China in Shanghai. Today I'm joined by a distinguished panel of experts to talk about reflow optimization of lead-free boards. Let me introduce them. On my right is Tetsuro Nishimura.
Hello.
He's the president of Nihon Superior. And next to him is Freddie Chan. He's the vice president of KIC's Asian operations. And next to Freddie is Dimock. He is the manager of process technology at BTU. Welcome, gentlemen.
Hello, yes.
Okay,
Hello.
Tetsuro, perhaps first question for you as a solder manufacturer.
Yes.
What have your experience been in the last few years with regards to lead-free alloys applied for reflow applications? Has there been movement towards tin copper nickel instead of the traditional SAC alloys?
Yes. As people know, I invented S1C based on tin copper nickel technology, and using a lot of this alloy for hustle and some surface finish on the PC board. And on the hustle, the printed solder paste and the reflow it. It's a beautiful connection can get. So this is the circumstances. So that's why these days people try to use low sag, even tin copper nickel alloy instead of tin silver copper because price-wise. So this is the recent situation.
Recent trend.
Yes.
Okay, Freddie, controlling thermal process variation, of course, is a very critical issue, and especially with a narrower process window with lead-free, right? Can you give us a general overview on the need for profile optimization or the need for high-quality profile?
I think profiling, especially now when you have a very small process window, I think it's very crucial now. If profile is now specified by all the paste manufacturer, defects will start to appear. So for us, when you go to a much more narrow process window, trying to get into the profile is going to be a challenge. So here in KIC, I think the market, especially here, has realized that, and we are doing very well now with our navigator software, which is now come standard with most of our profilers. So you can see that now, basically, you can say that in the China market or in Asia, we are, most of the SMT markets, they are using, I can say that a big percentage are using our navigator system. So this system has very easily and quickly helps to put you whatever profile that you need with the oven setting that is right for the particular process window.
Right. And Fred, with regards to the reflow oven, actually, for lead-free, how many zones are necessary? Because I know that your Pyramax models, you have between 6 to 12 zones, right? And will too many zones overcomplicate the oven? What are your views on that?
Yeah, there's been a lot of questions about the number of zones. Back in the beginning of using lead-free solder, there was a lot of arguments or a lot of discussion about that. At that point in time, BTU was making a Paramax 98 that had 7 zones, and that was 98 inches of heat. Okay. We also made one that was a bit smaller, and then also went to a 10 zone, 150 inches of heat. But the real issue is not the number of zones, but it's the time in the heat. Okay. In theory, you could take an oven that had temperature and convection and belt speed control, do a ramp to peaks profile in a single zone. Okay, in theory you could do it, but from a process viewpoint, that would not be very good. So, what people today are doing basically a 7 or 8 zone oven will work very well. It gives you the good division on when you need the ramp, when you have that short hole that you end up with lead-free, and into the spike. So that gives you good division for that. The real issue then is throughput through the oven. If somebody in the solder paste says to you, oh, it's going to take 3 minutes to peak, right? And that, you hear that a lot, maximum of 3 minutes to peak, then you need to be in the oven for a little over 3 minutes from the beginning of the heat zone to the end of the heat zone, not counting the cooler. Okay? Well, the only thing you've got in length of oven, in number of zones, is really the belt speed. So what happens is the people that have high throughput will step up to things with 120, 150 inches of heat, right? A medium belt speed, medium throughput would be like 125 inches of heat, with that 198 is about the right one. I personally would stay away from the shorter ovens because it gives you less flexibility.
So it's a matter of throughput.
A matter of throughput, right.
Okay, Tetsuro, from a reliability standpoint, right? Which alloy, in your opinion, has been known to produce perhaps less solder joint defects, perhaps reduce intermetallic growth, okay, and produce higher solder joint integrity? Because there's so many alloys out there in the market.
Well, I can say not so many alloys, but you know, just content silver, without silver, and some reliability issue of, from the standing point of component, cannot heat it up more than 200 degrees Celsius. So in such case, use bismuth content alloy to reduce the peak temperature. But it's a first things have to be make sure the fillet can say amount or solder amount or fillet height. You know, bigger size is better. Of course, reliability issues. However, the other things, let's say sidewalls and buoys, or even the head imperials. So it's a different matter because it's a kind of a solder problem, soldering problem.
Right.
So
And you have tin whiskers as well, other kinds of...
Okay, it's a tin whisker. It's related to the tin. It's alloy, but depend on the temperature. I mean the ambient temperature after reflow. Tin whisker, it doesn't happen at the reflow process.
Right.
You know, after the long reliability testing, does happen some tin pest under the minus 40 Celsius, and tin whiskers, it's a very high, not very high, at high heat, elevated temperature. So that's happened some tin whiskering. And you know, these days reliability issues, it's sound cycles, heat cycles. The coefficient of various component and PC board, its expansion ratio is different. So that's why some solder connection getting a brittle and that's break at last. So this is the big issues these days.
Freddie, let's go back to the reflow oven. With the popularity of dual lane and dual speed reflow ovens, how can we optimize the recipes in such ovens, especially when sometimes we get two different PCBs in the oven and both of them have different process windows. How can we do that?
When you talk about the dual lane oven, normally you put a smile on our face. Because when you talk about dual lane oven, you cannot get away from kick. What actually happens is, I think Frank will agree that when you have a dual lane oven running two different PCB, it's like almost impossible for you to set the oven up manually. It's almost impossible.
Yeah, I agree.
So you agree? So what we do is we use our navigator. So what we do is we will put a dual lane, two lane. We'll put two boards to run together. We set up the oven setup for the two different boards, and we run it through. We will try to get as close as possible to the required set points that you want. And then what we do next is we run it. The next round when we run through with the navigator software, we will just adjust the conveyor speed. We use the optimization feature to adjust the conveyor speed to the right profile that you want. And that's how we set the whole system. So come dual lane, you have to come to kick.
And Fred?
Oh, yeah.
That's very interesting. Fred, your
actually the thing that Freddie talked about is really a key feature to make it easy to do. There's a paper on our website that talks about profiling dual lane, dual speed ovens. There's also one on the KIC website that does the same thing. It allows you to give you kind of the ways to make that happen. Not all combinations of boards will be able to work on the dual lane, dual speed. You know, that's a problem in itself. But in general, a lot of people are able to make it work, and they're happy with it, because what it does is increases the throughput through a single oven. It saves them energy, and it also allows them a bit more flexibility in their process lines. There are some manual ways you can do it, but it's nowhere near as fast as you have some of these automated profiling things.
Okay, Tetsuro, I have an interesting question for you. As everybody knows, price of silver has gone up.
Yes.
Okay, lead-free process, you need higher temperatures.
Yeah,
but at the same time, people are looking for energy saving, cost saving. So my question is, what is the trade-off? You know, in which way do you save, either on the silver or in energy?
Of course, reliability issue. It's an energy necessary.
Right.
It's a price of the silver. It's a different matter, so cannot compare.
Perhaps you cannot compare. It's like apples and pears. Right?
Oh, that's right. And also one thing reminds me, it's a reflow profile and the reflow oven is very, very interesting for me, because soda, as you said, lead-free soda, much higher, not much, a little bit higher than the lead content soda, peak temperature, to melt the soda completely. And reflow oven, it's people say the temp time. It's a necessary to heat it up to active the chemicals, not for the alloy. Yeah. So that's why it's a kind of the trade-off. Time is important, or temperature is important. So that's a very interesting things for lead-free solvers.
And Freddie, for energy reduction and reflow, increasing reflow efficiency.
You know, like Fred just now was mentioning about using a manual way to run a flow file. But when you run a flow file using your own experience to set up the oven, you do not know whether you are overheating the board, or is it necessary to raise to the temperature. So what we do in KIC is we have a software called autofocus power. So what does this software do? When you set up the oven using this software will ensure that you go up to the temperature that is necessary for you to run this profile. You don't go over it. So in this aspect, we use this as with some testimony from some companies that after using our autofocus power, you reduce your energy consumption by 10 or 15%. So this is what we use to be more green.
And Fred, I'm sure some manufacturers come to you and say, my bill is too high. I want to save energy. So what
there are a number of things that can be done to lower the cost of operating a reflow oven. But you really have to talk about the total cost of ownership of the oven. It's not only energy or the material cost. It's things like downtime. It's things like product that failed when it went through the system. Okay, there's a lot more to cost than just the energy all by itself. Although the energy can be a big part of it. There's nitrogen costs, for example. There's a number of things involved. There are areas you can help. Things like controlling the startup of an oven. Some people in some areas get charged they call it demand billing, right? Where this peak demand adds a cost to the electric bill each month, and it can be fairly expensive. Okay, if you just slow the startup of the oven down a little bit, so you're going slower, you don't peak the thing out. Don't run it at maximum power as you're heating it up, or you stagger the startup of ovens. Okay, or if you've got 3 ovens and you start them all at the same time, your peak demand is going to be very, very high. But if you wait until one gets in, starts to be stable before you start the next one, you can lower those peak demands. Things like gas saver options, you can go to ovens. So when an oven is not running product, what you can do is lower the gas flow into the oven, so you're not using as much nitrogen. Other areas you can do it is by, we normally will run ovens, our ovens are designed to run at 50 parts per million or less O2 in a nitrogen oven. Well, we're hearing a lot of people saying, gee, they don't need that level. They can get by with 100 or even 1,000. Okay? By lowering the nitrogen into the oven, you allow the oxygen levels to go up a bit, right? And it lowers your cost. So we're seeing a lot of those. There's no magic pill.
Right. It's like the tweaking of the variables involved.
That's right. That's right. There's no magic pill.
Yes.
There are small incremental things that can be done to help.
Okay. Thank you so much, gentlemen, for sharing your views with us.
Our pleasure.
We
Yes.
appreciate it.
Thank you very much.
Thank you.
Thank you.
Thanks, Freddie.
Thanks.
Thanks, Freddie.
Everyone.